Assalamualaikum. This is a category theory lecture. Today I will define the definition of functor. Let's set C and D be two categories and F is a morphism from C category to D category. Associate each object X to each object Fx, where X belongs to the collection of objects in C category, where Fx is the object belongs to the collection of objects in D category. Second point is associate each morphism in C category, where F belongs to the home set in C category from X to Y to the morphism FF from Fx to Fy in D, where F belongs to the home set of D category from Fx to Fy. Okay, this morphism belongs to this set. Okay, what is the meaning of this set? Home f of x comma f of y, which means that the set of morphism from all the set of morphism from fx to fy. Okay, so the functor should be preserve two conditions. First condition, preserve composition, and second is identity. First is composition. First, preserve composition. How to preserve composition? Means f of g of f is equal to f of g compose f of f for all morphism from f from x to y and g from y to z, and the composition g of f from x to z in the category of C. Okay, for this, for all morphism, this, and should it should be preserve identity. So how can we preserve identity? Means f of id on x is equal to id on f of x for each identity morphism, where id belongs to the home set of x comma x and each x belongs to the object set of objects in C category. So how it should be preserve composition. Let's say f is a morphism from x to y and g is a morphism from y to z. So there is a morphism G compose F from X to Y by the definition of category. Let's say X associated to F of X in category D. Let's say Y can associated with F of Y according to the functor, and let's say Z associated to F of Z in D category. Okay. So according to the definition of functor, F associated to FF and G associated with F of G. Okay. According to the definition of functor send the morphism to morphism. Okay. So functor send G of F. So F of G of F from Fx to F of Z, but this should be equal to, according to the composition of these two morphism, f of g compose f of f. Okay, so this should be equal to f of g compose f of f. And if for identity morphism, how it preserve identity? Let's say identity morphism from x to x in category C. So according to functor, x associated to fx and x associated with fx. So according to the definition of functor, it sent morphism to morphism f of id on x. But according to this object, the identity morphism is equal to id on f of x. So it should be equal to id on f of x is equal to should be equal to f of id on x. So this two condition preserve. That's why this morphism f is a functor. First, f of g of f is equal to f of g compose f of f. And second condition, f of id on x is equal to id on f of x. That's why we can say f is a functor from first category to second category. Object sent to object of second category, morphism sent to morphism of second category, and should be preserve morphism, should be preserve composition and should be preserve identity morphism. Okay, Allah Hafiz.